Next, we want to install the Visual Studio Code in my system, and to do that I'm going to go to download in Visual Studio Code website, and I'm going to download the ARM64 version. Now if you're using x64 or different architecture, you need to choose that file accordingly, and I have already downloaded the ARM64 file here. And so as you can see, I have this file right here, ARM64, and if I run this command, it's gonna install the code. And since I have already installed it, it didn't do anything. Now if I want to see if the code is installed or not, yeah, I have it here. Click it, and that will open the window. This is the Visual Studio Code. And how do you connect to the server using Visual Studio Code? Well, the advantage of Visual Studio Code is that you can access the SSH server if you have that passwordless setup using this remote window option. So you can go to SSH, and there it's gonna install some extension automatically. Excuse me. And then click there again, that icon, and connect to a host, remote SSH. If I click that, since I have configured my SSH with the keyword moment, I have that one option here. If I click it, it's gonna connect to remote machine. Now I think I have access to remote machine. I can click open folder. I can open any folder there. So let me just open the home directory. Click OK. And I'm gonna close the other VS Code window. So here, yes, I trust the author. Here I have access to my server. And let me go to this qe.2 folder, and I have content here. So what I'm gonna do, I'm gonna go to that qe.2 folder using the terminal, and have a lot of content. I'm gonna delete all this content. And I see there's nothing now. So next step is to so this is my repository for Quantum Espresso, and here I have listed the executable and the file that executable takes, and which type of calculations it's gonna do for that particular file. And I have also listed some commands for SCF, NSCF, and other bands computation. And here I have written input files for silicon crystal. And so what I'm going to do, I'm going to copy this entire repository using this HTTPS, copy the link, and go to that terminal in my server inside that qe.2 folder, and I'm going to run git clone, paste the link, and I can see it copied Quantum Espresso. Now if I open my VS Code, I can see here I have all the files. So inside Silicon I have SCF computation file, input file, and one important thing is that you have this prefix correctly named. So for any Quantum Espresso computation, you have multiple files for a particular crystal, and all the files must have same prefix. Otherwise, if you run the computation, then it's not gonna be able to use the data generated in previous steps. And there's a file here. So SI is the silicon, 28 is atomic mass, and this is called the pseudo potential. And you can get this pseudo potential from online. So SI pseudo potential, and quantumespresso.org pseudo potentials. Let's go there, and it's taking some time. Now pseudo potential is important for almost all the computations. I'm gonna reject it, and it says let's go to that library, and there's a lot of files. I think what I'm gonna do, PWF, right? It's UPF, sorry, UPF. So now probably, yep, I have the file, silicon .upf file. So there are many types of pseudo potentials. Some are for non-relativistic computations, some are for scalar relativistic or fully relativistic. So depending on your need, you're gonna have to download only one of them. But here I have downloaded the pseudo potential inside this directory here. So and I also have an environment variable setup. So if I go to my home directory, cat the bash rc file, and grep, so I can see here I have one line inside that bash rc file. That line says export espresso underscore sudo equals tilde slash sudo. It means it looks for this directory inside the home folder. So as you can see, I have this sudo directory here, and all the files are there. If you don't have that folder, you can also specify the pseudo potential directory here in the control section of the input files. But for now, I'm just gonna use that that location. Now if you change the environmental variable here and define different location, then those pseudo potentials must be in that location. Okay, so now how do we run the commands? So here if you scroll down in my GitHub repository, you see there's the command. The way my Quantum Espresso is compiled is that you need to run this MPI run program, provide the number of processes, and then the executable for SCF computation -in for the input files. This is the name of the input file, and this arrow points to the output file that will contain all the log of this computation. So let me go to the VS Code and click this button, toggle panel, and that's going to open up a terminal here. I'm going to go to qe.2 Quantum Espresso inside Silicon. So I have the input files here. So I'm going to run mpi-mnp. I'm going to just use one process because I don't want to. So number of process means number of CPU cores, but for our computation here, I'm going to use only one CPU core and the GPU for our computation. So pw.x-in for input files, which is inside the input folder, then arrow scf.out. If I press enter, it's going to take some time. It's going to run the code, and so it says Fortran stop, and we can see it generated here SCF out file. If I look inside the SCF out, it's a big file. I can scroll down to the bottom, and I can see that it says job done. Every time you see job done, that means the file ran properly. If you see some other error message, you'll need to solve that error.